Okay, now we're continuing with our study of law of sines. We're going to talk about the ambiguous case of the law of sines, all right? What is meant by the ambiguous case, and how does it relate to the number of triangles? When given SSA, the law of sines can be used to find missing angles or the sign of missing angles. So this really only pertains when I have SSA. All right, let's get started. Triangle ABC. B is 12, C is 8, and sine of B equals 1/2. Find the value of sine C. So I just want to find sine C. I'm going to draw my triangle, just like we had with all these oblique triangles. They tell me little b, side B is 12, side C is 8, and the sine of B equals 1/2. So I can use the law of sines then to find sine C. So I've got 12 over the sine of 1/2. Oh, sorry. I made the mistake, everyone. I tell everyone not to. 12 over 1/2 equals 8 over sine C. There we go. Okay, so half of 8 is 4. So I've got 12 sine C equals 4. Divide both sides by 12. I get sine of C equals 4/12. All right, if you want to reduce it, sine of C equals 1/3. Either one of those would be acceptable, 4/12 or 1/3. Okay? And I like to kind of reduce it. All right, example 2. In triangle ABC, the measure of angle A is 30, A is 8, and B equals 12. Find sine B. So I've got A, B, C. The measure of angle A is 30 degrees. Little a is 8, and little b is 12. Those little letters refer to sides, of course. And I'm supposed to find sine b. So I have 8 over the sine of 30 equals 12 over the sine of b. All right? So that's going to wind up being 8 sine b equals 12 times sine 30. Now, sine of 30 is 1/2. I hope you know that by now. If not, you can use your calculator or your triangles. So half of 12 is 6, and that equals 8 sine B, which gives me sine B is equal to 6/8, or sine B equals 3/4. There we go. I like the reduced fractions myself. All right. So far, so good. Now, I want to find, in triangle ABC, they give me 2 of the sides, and they give me an angle. This is going to be side-side angle again. Find the measure of acute angle B to the nearest degree. So, I'm just going to use the law of sines here. When it asks to find an acute angle using the law of sines, well, this is kind of how it's done. We got radical 2 here, we got B is 1, and the measure of angle A is 45 degrees. So using the law of sines, I know radical 2 has to be over sine of 45, and that will be equal to 1 over the sine of B. Okay, so I'm going to get radical 2 sine B equals 1 times the sine of 45, which is radical 2 over 2. All right, so now I just need to divide both sides by radical 2 over 2. What might be easier, because this has a fraction in it, is to multiply both sides by the reciprocal of radical 2, 1 over radical 2, so they'll cancel. And you'll see they'll cancel there. So I have sine of B equals 1/2 after all that stuff cancels. Now it wants me to find B, so B equals the arcsine of 1/2. And the arcsine of 1/2 is 30 degrees. Okay, and that is an acute angle, right? It's that find acute angle of B. Right, that one was pretty easy because it was a special angle, and I recognized sine of 30 is 1/2. Triangle ABC, again, little a is 15, little c is 20, and this time the measure of angle C is 100 degrees. They want me to find the measure of acute angle A. So I have 15 over the sine of A equals 20 over the sine of 100. Now, I can't just plug in like what the sine of 100 is without a calculator, okay? I really don't know how to do that without my calculator or trig tables, which we don't have any trig tables. What I'm doing here is I'm simplifying this as much as I possibly can to get sine A, so that I can just round it off at once, okay? There we go. Now I'm going to need my calculator for the next part. I do 15 times the sine of 100, Okay, and that gives me 14.772 divided by 20 is going to give me 0.7386. And I want to keep 4 decimal places, 0.7386. All right, once I keep 4 decimal places, then I can do my arc sine of 0.7386, and that will give me my answer. Second sine, second answer, and I get, what's this? Rounded to the nearest degree. See that? To the nearest degree. So that is going to be A equals 48 degrees. And that is an acute angle, for sure. Okay, moving on. Now we're going to talk about what ambiguous means. Nothing about this has seemed too ambiguous yet. Well, ambiguous as an adjective means open to or having several possible meanings or interpretations. That means there's going to be possibly more than one answer, because sine is positive in quadrants 1 and 2, and an angle x in a triangle can be from 0 to 180, right? It's got to be less than 180. If it's 180 degrees, it's not going to be a triangle. But it can be right up close to it, certainly. Given SSA, the law of sines can yield 0, 1, or 2 triangles. 0, 1, or 2 triangles. All right, whether or not there's 1 or 2 are going to depend on this first rule here. Okay, and that is the fact that the sum of the angles in a triangle is 180. You're going to be given one angle, it's got to be that value, right? Then when you do the law of sines, you'll find another angle. You have a little bit of flexibility because if you do that angle as a reference angle in the second quadrant, for example, the sine of 30 equals the sine of 150, right? So 30 and 50 could be 2 possible answers, all right? So that's how I know if there's going to be 1 or 2. Do I have enough room for all 3 angles to add up to 180? And then the second rule here is going to be what's going to matter if we have 0 triangles. The range of sine is -1 to 1. So if I get like an arc sine greater than 1 or less than -1, then that's going to be 0 triangles. All right, when I'm asked how many different triangles, I like to set up this table right here, okay? And I'm going to fill it in. Given parts, the measure of angle A is 30. So no matter what, my A's are going to be 30. I'll fill both of those in right now. Draw a triangle ABC. Little a is 6, little b is 13. All right, and I also know that this is 30 degrees. So I have 6 over the sine of 30 equals 13 over the sine of b. All right, so then when I cross multiply that, sine of 30 there is 1/2. All right, sine of 30 is 1/2. So I've got 6.5 equals 6 sine b, because half of 13 is 6.5. Then divide both sides by 6. All right, so I'm going to get sine b equals 6.5 over 6. If I were to try and take the arc sine of that, watch, second, sine 6.5 divided by 6, it's going to give me a domain error. Right? Because 6.5 over 6 is greater than 1. Right? 6.5 over 6 is greater than 1. Therefore, there are no possible answers for B. If I can't have any answers for B, guess what? I have 0 triangles. All right? This came out to empty set, so that gave me 0 triangles. There we go. Moving on. How many different triangles can be constructed given the parts? Measure of angle A is 30, A is 8, and B is 10. So again, I draw my triangle A, B, C. Little a is 8, little b is 10, and this is 30 degrees. So, using the law of sines, 8 over the sine of 30 equals 10 over the sine of b. All right, so what I'm going to get here, sine 30, that comes up a lot in these problems here. 8 sine b equals 10 times the sine of 30, which is 1/2. Well, that's going to give me 5. So I have 8 sine b equals 5. Divide both sides by 8. Now I'm getting something that looks like a more reasonable answer here. Sine of b equals 5/8. So here we go. My b is going to be the arc sine of 5/8. Now keep in mind, this is going to give me an acute angle b. There's another possibility, b might be obtuse. So I'm going to put this here, and I'm going to try the arc sine of 5/8. and I get 38 point, let's just do the nearest 10th, 38.7. All right, so I get B equals 38.7. All right, so now we can start using this table. That was 30 degrees. No matter what, angle A is going to be 30 degrees. In my first triangle, I found B to be 38.7. Now, since the sum of all the angles in a triangle have to equal 180, is that possible? Like, what kind of value would I get for C? So 30 plus my answer from before, the 38.68 or 38.7, and then I subtract that from 180, 180 minus my answer, and round to the nearest tenth. So like 111.3. 111.3 degrees. And those are three reasonable answers for the angles. What's the possibility with the second triangle, though? Right? Since sine is positive in both the first and second quadrant, I could have a 38.7 degree reference angle here, and I will get the same value, right? So if I do 180 minus 38.7, I'm going to get 141.3. So that's my other possibility for B, 141.3. That's why it's ambiguous. There's more than one possible answer maybe here. Okay, so now if I add that to 30, which was my angle A, all right, I get 171.3, and take that sum and subtract it from 180, I get 8.7, which certainly is a positive number, right? So in this case, I was able to construct two distinct triangles. Two triangles. Okay, all right, moving on. Let's see what we got for our next example. Example 7. All right, how many distinct triangles can be constructed? Given parts, measure of angle D is 50 degrees, C is 15, and little d is 20. So I'm going to have to change these. I'm going to change this to D. We'll make this like C, and we'll make this like E. Right? It doesn't really matter what the letters are, okay? You just kind of want to use the ones that they give you. I could have used F or something. They just, they gave me D's and C's, and I picked the third letter. The measure of angle D is 50 degrees. Little d is 20. Little c is 15. I'm going to be able to find angle C. So 15 over sine of C equals 20 over sine of 50. All right? So I'm going to get 15 times sine 50. That's 1, 5 times sine 50 equals 20 sine C. So 15 times sine 50 over 20 equals the sine of C. Okay, and then remember, I'm going to keep this to 4 decimal places here if I get an answer here. 15 times the sine of 50 divided by 20 gives me 0.5745. So I have sine C equals 0.5745. Therefore, sine C. So therefore, C equals the arcsine of that. Right. Second sine 0.5745. I'm going to get, one of my possible answers for C is 35.1, we'll say. Okay? Measure angle D is 50, right? 50. And this one's 35.1. All right? That's certainly going to leave enough left over. And add 50 to that, and then do 180 minus that. Will give you 94.9. So that's 94.9. So that's okay. That adds up to 180. That's possible. The other possibility for angle C here, that is going to be 180 minus 35.1. All right? 180 minus 35.1. And you get 144.9. 144.9. Right? When I add that to 50, I have a little bit of a 144 0.9 plus